Joelle has two after-school jobs, babysitting and working at her parents' grocery store. Working at the grocery pays her $12 an hour, and babysitting pays her $9.50 an hour. Last week she worked 19 hours in total. That looks like a statement that could lead to an equation. Last week she worked 19 hours in total, and she earned $56 more at the grocery store than she did babysitting. That looks like another statement that could be an equation. She earned $56 more at the grocery store than she did babysitting. And then they ask us, how many hours did she work at each job? So they want to know, so let's define some variables here. Let's define time babysitting. So T sub B is equal to hours babysitting. Hours babysitting. Babysitting. And let's define T sub G as hours at the grocery. Hours at the grocery. Hours at the grocery. So they want us to figure out what was T sub B and T sub G. What were the hours at the babysitting and what were the hours of the grocery? Now, they tell us that she worked 19 hours total. So that blue statement says that the sum of these two is going to be 19. So the time she worked babysitting plus the time she worked at the grocery store is going to be equal to 19 hours. Now the other statement, this by itself, obviously we can't solve for these. We need another constraint. They said that she earned $56 more at the grocery store than she did babysitting. So let me define two more variables here. So this is the pay babysitting. This is the pay babysitting, her total pay babysitting. And let's say P sub G is equal to the pay at the grocery store. Now, what are these terms? I mean, if we just look at this second statement right there, we'll just say, okay, the pay at babysitting, she earned $56 more at the grocery than she did babysitting. So this second statement tells us that, well, I guess the pay, let me write it over here. The pay babysitting, she earned $56 more at the grocery than she did babysitting. So if we take babysitting and add $56, that will get us to how much she earned at the grocery store. That's what that second statement is telling us. $56 more at the grocery than babysitting. So if you add these two, you get the grocery. Now, this still isn't cool. We have 1, 2, 3, 4 unknowns and only 2 equations. That's not going to help us. But what will help us is we can express these two variables in terms of these two variables. And then we have 2 equations with 2 unknowns, and we can solve them the way we've solved all systems of equations. Now, the other information they give us is the rate, how much she earned per hour. Working at the grocery, she makes $12 per hour. Babysitting, she makes $9.50 per hour. So what is going to be her pay babysitting? Let me write this over here. Her pay babysitting, I'll do it in this color. Her pay babysitting is going to be equal to the time babysitting, right? The time babysitting times how much she gets paid per hour. The time babysitting is how many hours times how much she gets paid per hour. It tells us right there. She gets paid $9.50 per hour babysitting. So times $9.50. That is what her pay babysitting is. And then with the same argument, what's her pay working at the grocery store? Her total pay working at the grocery store, her pay at the grocery is going to be equal to the time at the grocery times the rate that she gets paid at the grocery, $12 per hour. So times $12 per hour. And this hopefully is intuitive. If I'm making $12 per hour and I work for, I don't know, 3 hours, I'm going to make $36. I would just multiply these two. If I worked 2 hours at $9.50, I'm going to make $19. That's all this is, the total pay. So now we can take these two expressions. We could take this expression and substitute it back into that equation right there. And then we'll have an equation that's only in terms of the time babysitting and the time at the grocery store. So let's do that. So this first term right here, her total pay babysitting, that is this expression right there. So let me write it right here. So $9.50 times the time babysitting. So I'll just write 9.5 times time babysitting. That's this term right here. Plus 56 is equal to the pay that she got at the grocery, which is 12 times the time at the grocery, which is 12 times the time at the grocery. And now we need to solve for both of these variables. We have two equations and two unknowns. This is just straightforward algebra at this point. So let's do it. So the easiest way to do this might just be to do straight up substitution, because we have all these crazy numbers here. Let's just solve for the time at the babysitting in terms of the time at the grocery. So if you take this equation, this top equation, let me write it over here. So the time babysitting plus the time at the grocery is equal to 19. If you subtract the time at the grocery from both sides, subtract time at the grocery from both sides, you get the time babysitting is equal to, these cancel out, 19 minus the time at the grocery. So we solved for the time babysitting in terms of the time at the grocery. So everywhere we see the time babysitting, we can substitute it with this expression right here. That's what t sub b is. That is what the time babysitting is. So let's do that. So this equation becomes 9.5 times the time babysitting, which we just figured out from this top equation is 19 minus the time at the grocery, plus 56 is equal to 12 times the time at the grocery. And now we just have to solve for the time at the grocery. So 9.5 times 19. 9.5 times 19. That's a little bit of a hairy. Let me just do it over here on the right side right here. So if I have 19 times 9.5, 5 times 9 is 45. 1 times 5 is 5, plus 4 is 9. And then we have a 0 here. 9 times 9 is 81. 9 times 1 is 9, plus 8 is 17. 17, so 5 plus 0 is 5. 9 plus 1 is 10. 1 plus 7 is 8. You just have a 1 there, and you have one number behind the decimal point. So it's 180.5. So 9.5 times 19 is 180. 180.5 minus 9.5 times the time at the grocery, minus 9.5 times the time at the grocery, plus 56 is equal to 12 times the time at the grocery. Now what's 180.5 plus 56? So 180 plus 50, let's add just those two terms. 180.5 plus 56, just to simplify it. 180 plus 50 would be 230. So this will be 236.5. 236.5 minus 9.5 times the time at the grocery is equal to 12 times the time at the grocery. Now, we can add the time at the grocery to both sides of this equation, or the 9.5. So let's do that. Plus 9.5 times the time at the grocery is equal, or plus 9.5 times time at the grocery, just adding it to both sides of that equation. And we are left with the left-hand side, that cancels out. We just have 236.5 is equal to 12 plus 9 is 21. So this is going to be 21.5. It's equal to 21.5 times the time she spent at the grocery. So now we can just divide both sides of this equation by 21.5, and we figured out how long she spent at the grocery. So let's do that. Divide both sides by 21.5. So that cancels out. The time she spent at the grocery is going to be equal to that thing. And let's see what that is. We get 21.5 goes into 236.5. Let's multiply both of these numbers by 10. So this is the same thing as 215 going into 2,365. The decimal goes right there. 215 goes into 236 one time. 1 times 215 is 215. And then we can subtract. Let me scroll down more. This problem is hairier than I thought it would be. So 36 minus 15 is 21. So 21. Bring down the 5. And lucky for us, that's pretty straightforward. 215 goes into 215 one time. 1 times 215 is 215. Subtract, you get no remainder. So the time at the grocery store is 11, or 11 hours. Now we can go and substitute back to figure out her time babysitting. We know that the time babysitting is equal to 19 minus the time at the grocery. In this case, it's 19 minus 11. We just figured that out. 19 minus 11 is 8. So her time babysitting, she spent 8 hours babysitting. And we are done. They both add up to 19, and you can make sure that they also verify that also works out for the second equation.